Okay, gentlemen. So today we are going to start chapter number 4, critical path method. It's part 2. We are going to discuss part 2. Today's lecture is very important because more difficult things we are going to discuss. So allow me to say Bismillah, Alhamdulillah, wassalatu wassalamu ala Rasulullah. Rabbi shrah li sadri wa yassir li amri wahlul 'uqdatam min lisani yafqahu qawli. Assalamu alaikum wa rahmatullah to each one of you. So we are going to discuss chapter number 4, part 2, where we have left last time. Last time, if you remember, in part 1, we have discussed about the critical path. That critical path is the longest continuous path in the network diagram, and it gives the shortest duration for the project. We also discussed about how to find a total float and free float. Like total float is the amount of time an activity can be delayed from its early start without delaying the entire project. Similarly, we discussed free float is the maximum amount of time an activity can be delayed without delaying the early start of the succeeding activity. So succeeding activity. So, if you remember, so we discussed two examples how to draw the diagram. And in today's lecture, we are going to discuss mainly these like the outline, we will address constraints in the CPM's scheduling, and how we are going to deal with constraints in the critical path. And we will see end of day convention, how computer, or when we draw diagram, how we understand. So then we draw the network diagram with the lags. So we will also discuss a little bit about the driving relationship in the critical path method and event times, effect of imposed finish date on the schedule. Negative float, we'll discuss. This is very important how we deal with the negative float. Then we will address about management float or time contingency. So constructive acceleration will be addressed, and then crews following different calendars are dealing with the calendars. How we are going to deal with the calendar. So these kind of things we are going to discuss, inshallah, in today's lecture. So it's a very important lecture and little complicated, because last time chapter 4, that part was easy, and this is a little advanced part. So let's move. So we have discussed this example number 2 in the previous lecture, and we draw this diagram, and then we find the forward pass and backward pass, and then we calculated the total float and the critical path. Okay? So we have and then we calculated also these total float for critical path is 0, and for the other activities total float is shown as in this diagram. So we will take this example to move to this second part of today's lecture. To start this example we have discussed in the previous lecture. Okay, so let's move to the next slide. So so we are going to discuss constraints and the CPM. Okay? Constraints, so simple things. Let's see. A constraint is an externally imposed restriction affecting when an activity can start or finished. Okay, so it's externally, sometimes client, they are going to put, okay, this is the project start date is this one, okay, project finish date is this one, or you can start the project on this section on this date. Okay, so this is like clients, they are going to put some constraints. Constraints may conflict with the logical relationship. Okay, so if you are prepared for a relationship, your schedule, so then they can conflict with that one, or constraints are not alternative for logic. Okay, so they are not alternative for the logic, so they can conflict. Here, constraints in the software, the software like individual software program provides the user with a variety of constraint types, some of which can override logic and some of which are subject to logics. Okay, so different software, they show different kind of constraints. So we will show here some name and rules differ from one software to another, and users must practice caution. Okay, so like we say, okay, start on this date, or start on or before, or start on or after, finish this activity on this date, finish on or before this date, okay, finish on or after this date, as late as possible, finish as late as possible. So there is a mandatory start, or there is a restriction that from the client to finish the project on this date. Okay, so mandatory finish. So these are like the constraints. So we will see all these things with the examples. So there's no need to worry. It's that we will see in examples. So we are going to discuss chapter 4 with the part 2. Okay, so take the same example that we have discussed before. That like this example before. So here the constraint what we are going to put is if you see like activity H is here is going to mention that start on or after day 24. So it means activity H we are going to start on or so instead of 18, so starting will be day 24. Okay, instead of 18. So then, like this, we have the schedule. So here you can see the finished time is 27 days. Okay, in this diagram. So 27 days, as we have seen before. So critical path of this diagram. If you remember, critical path also is A, B, E, G, J. Okay, A, B, E, G, and J. So then, when we talk about the constraint on this diagram, so like activity H will start on or after day 24. Okay, so we will in like this is the first critical path. Now, when we put start this on or after day 24, so now it will look like this. Instead of activity H starting on day 18, it is going to start on 24. Okay, so 24 plus 5 we got for H is 29. So forward path will come here at 26. D is 26, going to finish on 26, H on 29, and I on 22. Okay, so then J become 29 and 30. So before it was going to finish on 27. Now the project will finish on 30th. Okay, so it has taken 3 days more. So now we will do the backward pass with this project duration has become 30 days. Okay, so we do the backward pass with 30 days, and then we find the total float. Okay, then we find the total float for this. So we do the backward pass like J is 30 minus 1 is 29. So 29 comes for I is 29. Minus 425. So similarly, 29 comes under H. Then minus 5 is 24. Then 29 will go to G. 29 minus 8 is 21. So we are doing backward pass. Okay, so for the whole diagram. So this for D from G, this 21 will come here at D is 21. Minus 5 is 16. Then for E is we have, three activities following. Here it's 20, from G 21, from H is 24, and from I is 25. So we take minimum is 21 minus 6 is 15. So similarly, then we go back to activity F. So this 25 will come here, minus 3 is 22. Then for C as we have 15 and 22. So we take minimum 15. And then for B is we have here is 16 and here is 15. So we take 15 minus 7 is 8. And then 8 and 11 we take 8 comes here. So we got 3. So now you can see is a total float for A become 3, total float for A has become 3 minus 0 is 3, like 8 minus 5 is 3, 16 minus 12 is 4, and similarly 15 minus 12 is 3. So you can see that the float for the critical activities, before having critical activity A, B, E. So now there is a float for these activities by increasing 3 days duration, because H instead of starting 18, now we have started on 24, okay, 24. So there is 6 days, we have taken 6 days more. So this is the constraint, start on or after day 24. So it's going to affect the critical path. So see, it's project duration has become 30th. Okay. So with this, calculating critical path with the constraint. Okay, so diagram shows that these activities, like if the previous project is constructed, then activity H has become critical. Okay? So before H was not critical, but G was critical. In the previous with the 27. Total duration, G was critical. So our critical path was A, B, E, and G before, okay, and then J. So now it has changed from H to J, okay. So this path has become critical. So this is like the effect that we are going to see, that how it's going to affect the critical path with the constraints, okay? And we change the deal with the constraints. So then it will affect our critical path. Let's take another example. Like in this example is activity F. Activity F, we are going to start, late start on or before day 10. So instead of starting activity F on 19, this is the original, diagram, example 2. That we have a total duration is 27 days. So now we apply the constraint on this diagram. Constraint this time question is that start activity F, late start of activity F should be on day number 10, okay, instead of 19. Okay, instead of 19, so we will start it on day 10. So when we start here on day 10, so here instead of 19, it will become 10. Okay. So 10 plus 3 is we will get here 30. Okay. So now let's see in the next, we will see this. This is actually the previous original example 2, that the total duration is 27 days. Now we will apply. So here you can see the critical path is A, B, E, G, and J. So now we will apply on this constraint. Recalculate the float with constraint. Okay. So we will apply the constraint late start on or before day 10 for activity F. Okay. So when we do this one, so now here we have applied that instead of starting on F starting on 19, we are going to start late start is 10. Okay. Late start is 10. 10 plus 3 is 13. So then, but see, because here it will not affect on I. So here we will take the maximum from E. It comes, from E it comes 18. And then here is 22. So it will not affect the other activities. This. But when we come back from this, because it has started 10, so it's 3. And when we come back from here, it will become like for C is before C was 11 and 15. But now when we see here is from E, we will get 12. From F is 10. So 10 will come here for C for the backward pass. Okay, for the backward pass. So it's 10 minus 4 is 6. So only these two activities, they are going to change just activity C and F. C and F, but there is no effect on the other activities because of this constraint. Okay, so this constraint has changed only some few activities, but there is no effect on the critical path. Critical path is same as before, but total float has changed. For C is before it was 6 days. Now it has become 6 minus 5 is 1 day for activity C, and similarly for activity F, it is total float is 1 day. Total float is 10 minus 9 is just 1 day. Okay, so this has changed to 1 day. And similarly here, before we were having a total float for this activity I is I was before it was more, but it has changed a little bit. So there is just effect on C and F. Okay, C and F. This has affected. Okay, so it means, but there is no effect on I, and there is no effect on any other activity because of this change. So here, when we take forward pass, it's 18 and 12. So it comes 18 for I, and plus 4 is 22. Okay, so then it comes 26. And similarly, when we come back from here, so it's 26, then 22, then from here, it becomes just 13. Okay, so and there is it's not going to affect the other activities. So just this constraint has affected activity C and F only. Okay, C and F only. So let's see, now we have taken two examples. One time we have applied this constraint on activity H, and the other time we applied this constraint on activity F. Okay, let's take the other example. Okay, let's take the other example is example number 3. So this time we have this activities table A, B, C, D, L. Duration are given, and immediately preceding activities are given. Okay, so from this, if this list is given to us, then we can draw the diagram. We can draw the diagram for example 3. So when we see this, we draw from this table, we draw the diagram. So you can see that A is the starting activity, IP is nothing, and B is 6 days, and it is after A. C is 5 days, it is after A, and D is 3 days, and it is also after A from the table. So you need to keep in mind, the previous slide, and then you will see that activity E is after B, duration is 3 days. Activity F is after B and C. B and C duration is 4 days. And then activity G is after D, is duration is 4 days. So activity H is after B, C, and G. Okay, activity B, C, and G. Okay, so duration is 7 days. And then we can draw the I is after E and F. So duration is 8 days. And then we can draw the J is after F. So duration is 2 days. K is after G and H. So duration for K is 3 days. And then L is after I and J. So duration is 2 days. And then, so both activities L and K, they are in space. So we put the project finished date. So to make a common point for the finish of the project. Now we have drawn the diagram from the previous this table. From this table, we got this diagram, and then we will do the forward pass. Okay, we'll do the forward pass like here. Do the forward pass and backward pass and find the critical path. Okay, so here you see forward pass like A is duration 505. Here we go 5 plus 6 is 11. For C is 5 plus 5 is 10. For D is we got from A 5, and then plus 3 duration is 8. And then when we go for E, so this 11 will come here, plus 3 is 14. For F is we have 2, 11, and 10. So we take maximum. When we go for forward pass, it's 11 plus 4 is 15. And then for G is just 8 comes here, plus 4 is 12. Then for H is we have previous activities, 3 preceding activities. So it's 11 and 10 and 12. Okay, so we will take the maximum. All 3 should finish, then H will start. Okay, so 12 plus 7 is 19. And then we come to the J. So this 15 will come here, plus 2 is 17. For I is we have 2 previous activities, E and F. Okay, so with this arrow here, E is going to finish on 14 and F is on 15. So both should finish, then I will start 15 plus 8, 23. Okay. And then we 23. So then we go to L is 23 and 17. So we take maximum 23 plus 2 is 25. For K is 17 and 19. So then we take 19 comes here, maximum, then plus 3 is 22. So then from 25 and 22, we got 25. So by this, we got 25 is the project duration. Then we do the backward pass with 25. So 25 comes here, minus 3, 22. 25 for L is 25, minus 2, duration is 23. Then we go for I is 23, will come here, minus 8 is 15. For J, we have 22 and 23. So then we will take the minimum when we come backward pass. Like if K has to start on 22, so J must finish on 22. 22 minus 2 is 20. So for H, we got this 22 here, minus 7 is 15. And then for G is this 15 comes here, minus 4 is 11. So then we have J here, and I is 15 and J is 20. So for F, 15 comes here, minus 4, 11. For E is this 15 comes here, minus 3 is 12. Then for B is we have to look 3 activities for, after B is E 12, and then is 11, F is late start is 11, and then this H is late start is 15. So we take the minimum. So 11 comes here, minus 6 is 5. And then for C is, so we have to look 2 activities. One is C is this 11 comes here, okay, and then 11 minus 5 is 6. So similarly, for D, this 11 comes here, minus 3 is 8. So now we have for A is 5, 6, and 8. So 5 comes here, minus 5 is 0. Okay. So total float for this, we can find the total float for this one is like find the total float. 0 minus 0 is 0, then 5 minus 5 is 0, 11 minus 12 is 1. So its total float is shown with green. And for the critical path, because it's 0, it's not shown. Okay. So 6 minus 5 is 1, 11 minus 7 is 0, 8 minus 5 is 3, 11 minus 8 is 3. Then for H is 15 minus 12 is 3, for J is 20 minus 15 is 5, then for I is 15 minus 15 is 0. Okay. L is 23 minus 23 is 0, K is 22 minus 19 is 3, and for project finish is 25 minus 25 is 0. Okay. So we got total float for activity C is 1, for D is 3, for E is 1, and for F is 0, like A is 0, B is 0, F is 0, then I is 0, total float. For L also total float is 0. And similarly for G is 3, for J is 5, for H is 3, for K is 3. Okay. So this we can put in this table, like how much is activity A, B, C, D up to L. Then we can put how much is the early start time, early finish time, late start time, and late finish time. Okay, what from the forward pass and backward pass, and then we put the total float for each activity that we have calculated. Similarly, we can calculate the free float. Free float is linked between two activities, like for A. So early start of B is 5. So early finish of A is 5. So 5 minus 5, we will get 0 for A. Even we see from here, for C is 5 minus 5 is 0. And for D is 5 minus 5 is 0. So all for A, we got a 0 total float when we check that there are 3 falling or successor activities after A. So this free float is linked between two activities. So we have to see for A that there are 3 successor activities. So we have to check 3 times and see take the minimum. Then for B, so there are 3 activities following E and F and H. Okay. So 11 minus 11 is 0. So it means we can put 0. Or from F is also 11 minus 11 is we got 0. But from H is 12 minus 11 is 1. So we take the minimum. So it's free float is 0 for B. And similarly for C, free float is 1, because it's 11 minus 10 is 1. Okay. Or if we take from here 12 minus 10 is 2, so we take the minimum. 11 minus 10 is 1. Okay. And similarly for D is total float 8 minus 8 is 0. So free float is 0 for activity D. And for activity E is just 15 minus 14. 15 minus 14 is 1. And for F is, so we have to 15 minus 15, it will become 0. And for G is 12 minus 12, it will be 0. And free float for I is again 23 minus 23, it will be 0. And for J, it will be like 23 minus 17 one time, and then 19 minus 17, so it will be 2. Okay. So we have to take minimum 19 minus 17, it will be free float will be 2 for activity J. And then for H is 19 minus 19, it will be 0 free float. For L is 0, 25 minus 25 is 0. For K is 25 minus 22. Okay, so it will be 3. Okay, so these free float we put here. We fill this table. So from this example, like we draw the diagram and then we did the forward pass, we did the backward pass, and we find the total float. So all those activities having zero total float, they are on critical path. So activities A, B, F, I, L, and project finished. So they become the on the critical path. And then we find the total float and also the free float. Okay. So with this, we finish this example, and now we will see this end of day convention. Okay, the dates on the activity represent the end of day. So dates on the activities represent the end of day. That's why we always start with the day zero. Okay, so when we say day zero, it means end of day zero means the start of day one. End of day zero means start of the day number one. So when we put this, from the starting activity, that is the starting time is zero. So actually, that will be the end of day zero. So it means it will be like marking the start time of day number one. So this concept is not applied in computer programs. In computer programs, start dates like the early start, late start, represent the start of the day, while the finish date, early finish, late finish, represent the end of the day. Okay? So it's just when we start with zero, but the computer understand it's like for A is one. One means like this the start time for day number one. Okay, and duration is 5, so it will be like early start is start time of day number one, and early finish is like 5, so it means end of day number 5. Computer understand this way, like finish so early start, early finish. Okay, so early finish time will be 5. Okay, and similarly late start it will be 1. Then late finish will be 5. Okay, so similarly for B it will be like so this 5 days. A has taken 5 days. Okay, so B will a computer understand like day number 6 is the starting time for B. Okay. So, and day number 11 will be the finish time for B. Okay. And similarly for C is like 6, it will be the starting time for day number 6 will be the starting time for C, because A is the A for A duration is 5 days. So 5 days has gone, day number 1, day number 2, day number 3, day number 4, day number 5 for A. Similarly for C is so day number 6 will be the starting time, and then plus 5 duration 10. Okay. So this is the way that computer understand these. So when we do calculation, we start with 0. Okay, but computer understand that it's the start time of day number 1. Okay, so this is that you need to understand this solution with using a computer, how computer understand early start, late start, or early finish, or late finish, okay, for all the activities in the network diagram. So this will move to the next. So let's see as general comments. Critical activities are important. Critical activities are important, so we have to pay special attention to those one. A project manager needs to decide on dates within the range of early, late dates. Okay, so. But computer program by default use early dates. Delaying is possible using constraints. Okay? So computer program by default use early dates, and delaying is possible if we are putting some constraint. Okay? Never give a subordinate 2 sets of data. Okay? So be careful if you are a planning engineer. So don't give like 2 sets of dates to the site people. So give just the one schedule, that is they are following or they understand better. You know? So don't confuse them by giving these different date how computer understand. It's the computer understanding is this way, and your understanding is like you start a project with time 0. You know, so but computer start with day number 1. Okay, so you have to give just to keep one schedule that you are going to give to the site people. Then management may reserve a number of days as management float or time contingency. This we will, you will understand that sometime if the constraint is we have calculated the duration and from the Primavera, but so we put the start date of the project. So if we then we calculate, let the computer give us the finish date. Okay. So now your contract date is maybe more than that. So if it will be more, it means so you are planning to finish the project a little early, whatever the contract finish date. So in that case, that will be like the time available with the management. Okay, or we can say it's the time contingency that management can keep in mind that according to schedule, we are sure that we can complete the project little early. What is the finish date? So it means you will be better off, you know, if this situation occurs. So we will explain this more with examples. Now let's see the float discussion. Question is who owns the float? Okay, so answer is usually who uses it first. Generally, it is owned by the contractor. So contractor is the real person who do the work on site. So really contractor, project manager, so they understand better about the schedule, and the planning engineer also belongs to the contractor, so they use the float. But sometimes owner or their consultant, they ask that they want to use the float, you know. So then they have to agree on that one. So maybe there is a delay in the delivery of drawings or something. So then they have to sit and agree on that these drawings or design should be available without delaying the project. If resource leveling is used, almost every activity becomes critical. Now, if we do the resource leveling, so then it means activities become critical. You know? So this is another case that when we deal with the resource leveling, or free float may be affected by preceding activity. Free float always is affected by the preceding activities because it will not have any effect on the succeeding activities. Okay, so free float is linked between two activities. It will be just linked between two activities, so previous activity and this activity. Okay, so it will not affect the start time of the next or succeeding activities. So it's you know. So yes, we have done it. Okay, we were here. Okay, so this like free float may be affected by preceding activities, but will not affect the succeeding activities. Okay. So let's move. Next is shifting activities with their float may affect. Okay. And if we are going to shift activities with their float, it will affect the start or finish date of the succeeding activities. Okay. So it will also shift activity like resource uses, labor, equipment, and crews. So what time we need this labor or what time equipment or this crew have to start the work. So these things will be affected. You know, material delivery or what storage. Shifting activities within their float may affect all these things. Okay, then lags. Okay, so next we are going to discuss how to work with the lags. Okay. A lag is a minimum compulsory waiting period between the start or finish of an activity and a start or finish of the successor. Okay. So it's a lag is like an activity with duration, but no real work or resources or budget. Okay. The lags are very common with start to start and finish to finish a relationship. A lead is a negative lag. And lead is a negative lag. Okay. So we will solve example C, and you understand better. So how we differentiate between lag and lead? Think of lag as after. Lag means that it will be like next activity will start with so many days of lag. Okay, so it will be like after. And lead as before. Okay? So lead means the successor activity will start so many days early. So this is like before. Okay? So lead is always in negative, numbers given. So like here, this is like place concrete 2 days, and then there is a 3 days lag, and then strip the formwork. So 3 days, maybe we are doing the curing for the concrete, and then we will remove the formwork. Okay. So here a concrete curing before formwork stripping. Okay. There is a 3 days lag, and then we are going. Then we think concrete is going to set, and we can remove the formwork. So this is how the lag works. Waiting for a permit to be issued. Okay, so then that we can put in the lag form. Okay. So lag is always like an activity with duration, but no real work or resources. So it's like a waiting period. Waiting for a permit to be issued, waiting for a material or equipment to be delivered. Okay. So this will be, we can mention in terms of lag. Like in this example, we have seen place concrete for 2 days, then there is a 3 days lag. It means that then we will remove. So curing work will continue, but then we will remove the form work for then that concrete that we have placed earlier. So in this example, the successor cannot start until at least 3 days after completion of the predecessor. This is the meaning that successor cannot start at least 3 days after the completion of the predecessor activity, like placing a concrete. So then stripping formwork will start after 3 days. Okay, this is like the lag meaning. Now, in this example, we have activities A, B, C, D, E, F, G, H, I, and then duration for each activity is given. Immediately preceding activities are given, and lag are given. So there are 3 lags, like there is a lag for when E will be after B and 4 days lag. So G will be after F and then 3 days lag. So H will be after G and 2 days lag. Okay. So we will draw this diagram like, when we see this, remember this figure, this table, then you can draw the diagram. Okay. So it means like A, B, C, they are 3 starting activities. Okay, there is IPA is nothing, so it means they are the starting activities. And D will be after A, E will be after A, and E will also be after B with 4 days lag. So let's put this diagram. So there are 3 activities A, B, C with A is 5 days, B is 3 days, C is 6 days. So then these are the 3 starting activities. We put a common project start node. We introduce ourselves to make a common starting point. And activity D is after A with 7 days duration. E is after B with 7 days duration, and E is also after B with 4 days lag. Okay. Then we have a G activity F. F is 4 days duration, and it is after A, B, and C. So we draw these 3 lines, A, B, and C. Okay. F is after A, B, and C. And activity G is after E. G is after E. And also activity G is after F and 3 days lag. Okay. So for H is after D, and then H is after G with 2 days lag. 2 days lag. So there are 3 activities with lag. E is after 4 days lag from B, and G is after 3 days lag from F, and H is after 2 days lag from G. Okay, so then we draw this activity I. Activity I is after D and G, and duration is 3 days. Then we have two activities in the space H and I, so we introduce ourselves a finish a project finish project finish node, and we do the forward pass and we do the backward pass. Okay, so we by this, when we do the forward pass, like here 0, 5, 0, 3, 0, 6, then 5 comes here, 5 plus 7 is 12. So here is 3 plus lag. Okay, plus lag, then we got 7 here, plus 7 is 14. And then for F is, so we say 5, 3, and 6. So 6 comes here, plus 4 is 10. Okay. Then for G, from E, we got 14. From F, 10 plus 3 lag is 13. So we put 14, plus 5 is 19. And then for H is when we take from D, 12 should come here, but from G is 19 plus 2 days lag is 21. So 21 plus 6 is 27. So similarly for F, I is so from G it goes 19 here, plus 3 is 22. So now we have 27 and 22. We got the project finished date is 27. So this is like we make practice of how we draw the diagram with lag, and we do the forward pass. Similarly, we will do the backward pass. So like to start from the end with 27, and 27 minus 3 is 24. 27 minus 6 is 21. So then 21 minus 2, we got 19 here. By this is 24. So we have to take the minimum and come back. 19 minus 5 is 14. So then 14 minus 3 lag is 11. Then for E is this 14 comes here, and for D is we have 21 and 24. Okay, so 21 comes here, minus 7 is 14, and then from for A we have three activities. 14 and 7, and then here 14 and 7, and yes, 7 again for F. So for A is 3, yes. Yes, F is also following activity or the successor activity for A, so it's 7. So we got 7 here, 7 minus 5 is 2. Then for B is, we have to see that 7 minus 4, we got 3 here, or from F, 7 goes here. No, take minimum. So 3 minus 3 is 0. So then it's this 7 comes here, minus 6 is 1. Okay. So by this, we have drawn this diagram, forward pass and backward pass, and then now we can find the total float. Total float now here is 0, 0 minus 0 is 0, 7 minus 7 is 0, 14 minus 14 is 0, 21 minus 21, 0. So all those activities where we have for A, total float will be 2 minus 0, it will be 2. Okay. And for B is 0, for C is 1 minus 0, 1. So for D will be 14 minus 5. Okay. For D will be 14 minus 5 is 9. And for E is 0. For F is 7 minus 6 is 1. And total float. And then for G is 0. And for H is 21 minus 20, 0. Then for I is 24 minus 19, we got 5. Okay. So we find the total float, and then we can find the free float also. That is 0. Then from A to D, 5 minus 5 will be 0. For B is we have to see 2 times. One is 7 minus 4, 3 minus 3, 0. We got 0 for B. And otherwise, we go from here as 6. 6 minus 3 is 3. Okay, so we take the minimum. And then for C is 6 minus 6 is we got 0. For C, And similarly for others, we find the total float and free float, and then we list in this table. Okay, early start time, early finish time, late start time, late finish time, total float, and free float. Okay. So after this, now we have finished this example. This was an example with the lag. Okay, how to work with lag, or how to draw a diagram with the if lag is given. Okay, this was important to make practice. Then next point we are going to discuss is the driving relationship. Okay, so like when we have a driving relationship from a predecessor activity that control the start or finish of a successor activity. For any activity with predecessors, there must be at least one driving relationship. Okay, if the activity has three predecessors, so then at least one will be the driving relationship. You know, that we will follow for the critical path. So we will see that which way we are going to get the critical path. Okay, that path that is continuous. You know, so that will be driving relationship. Removing the non-driving relationship is not a good idea for the sake of above argument. Okay, so we know that we have to move forward with the driving relationship, but we will not disturb the other relationship. Okay. So any activity can have more than one predecessor. Okay, any activity can have more than one predecessor if there is a predecessors are more than one. Usually, but not always, only one relationship is driving. Okay, so there is among the three predecessors, there will be one relationship will be driving. This may change if conditions preceding that activity change. Okay, if we put like duration is going to change, or we put a logic change, or we put some constraints, or we did have done the resource leveling. So this will affect this to the driving relationship also. They will have an effect on the driving relationship also. So like this example we have discussed before. Okay. So with 27 days duration. So now this example, you know, driving and non-driving relationship. So like from B to E. So this is driving relationship, and from like you know. From say for example, E is before E are two activities. Okay, A and B. Okay, so what will be the driving relationship? That relationship will be continuous. Okay, 3 plus 4, we got 7 here. So this relationship is continuous. Okay, but here we have 5 and here we have 7. So then this means this is not a driving relationship. So we have to see which relationship give us the continuous time. Okay, there is no free time. That will be the driving relationship. Okay, let's move now. They are asking that to make practice if A's duration has increased to 8. Okay, like this diagram. Now duration for activity A has changed to 8 days. Okay, then do the forward pass, backward pass, and see how the diagram look like. Okay, and then they say you can make practice if activity C duration has decreased to 4. Okay, instead of 6 days, duration has changed to 4 days. Then see how this is going to affect the whole diagram. Okay, make practice there by this way. Or for activity F, so like put the constraint is duration for F has changed to 6 days instead of 4 days. So then see how this do the forward pass, backward pass, and how this will affect your diagram. So this you know make practice with the how to deal with the lags. Okay, do the forward pass and backward pass. How we are counting the lag? It's like duration of the activity. You know. Then next we are going to discuss is event times. Okay, event time like in the arrow diagrams. They always have event time. Okay, when we start like here is node 10. 0, and activity A duration is 10, B is 5, C is 7 days. So then we did the forward pass 0, 10, and from B is 0, 5, for C is 0, 7. And then for D here, so if this 10 comes here, plus 8 is 18. Then for E is 10 and 5, so 10 comes here, plus 9 is 19. For F is this 7 comes here, plus 4 is 11, forward pass. So now this is, node 50 is going to finish 18, 19, and 11. So we take the method 19, then G will start on day 19, plus 5 is 24, H is 19, plus 8 is 27. Okay. So by this dummy activity, we got 27 days. So now even time means that node A event is 0. Okay. Node at 20. So this is like we do the forward pass and backward pass. So when we do the backward pass, also this 27. So to start with 27, come back. This 27 minus 8 is 19. So 19 comes here. Okay. Here 27 minus 5 is 22. Okay. So this node is like a node for 50. So forward pass also gives 19 days duration, and backward pass also gives 19 days. Okay. Similarly, if we go to node number like 20, so forward pass put its duration for activity as 10 days. Okay. Similarly, when we come back from like activity E 10 days, so 10 will come here. So the event time will be 10. Okay. And similarly for 30th is 10 days, for 50, node 50 is 90 days. So this is like arrow diagram, they have the node, event time. Okay. But event time for node 40 will be, with the forward pass will be 7, and with the backward pass will be 15. Okay. So and here it gives 19 minus 4 is 15. So here from 0 to 7, so forward pass gives 7, but backward pass gives 15. Okay, so this is like a arrow diagram. They give us the event time. Now we are going to discuss the effect of imposed finish dates. Okay, imposed finish date is the project's completion date as specified in the contract or stipulated specified by the owner. Okay? So imposed finish date something the owner give the project duration. So then they fix the start, okay? And then we got the project imposed finish date. So owner will define that project starting time is this and finish time is this one. Okay. So now it is a good practice for a scheduler not to enter the imposed finish date until the project finish date is calculated by CPM. So when we work with Primavera, we enter just the starting date. Okay? And then we do the scheduling with all the activities and we see how is our finish date with this schedule. Okay. So then we see if our finish date is early and then contract finish date is more, then we are better off. That means we can finish the project within that time or early than that one. Okay. So after the finish date is calculated, it is compared to the imposed finish date. So now that you have entered the start date, and then computer will calculate for you the finish date. And then we can compare it with the contract or imposed finish date, whatever the date is given by the client for the project. So if now what they say is a calculated finish date by the computer is less than the imposed finish date, it means you are in good shape. It means you can finish the project early. What happens if you enter the imposed date? Or because the duration with the imposed date is more than what the computer has calculated, for your schedule. So if you enter the imposed finish date, then your critical path will disappear. So now in other cases, if your calculated finish date is more, like you enter the starting date and you enter for every activity duration, everything. So you have finished your schedule. So now you see your finish date, what you have calculated from the Primavera. So then compare that with the imposed finish date. Now your calculated date is more, imposed finish date is duration is less. So what it means that there is a negative float appears when you enter the imposed finish date. Okay? Because you are already, your schedule is longer than the imposed finish date. So it means that there will be a negative float. So in that case, either you need to accelerate the project, you need to speed up the project, or you need to crash the schedule. Okay, so you need to reduce the duration of the schedule. So this is either way you can do. So in that case, so now they are asking that to make practice for this one, let's put repeat example 3 with imposed finish date of day 28. So if you remember that example 3 was finish date was 25. So now repeat example 3 with imposed finish date of day 22. Okay. So our example was with what we have calculated before. So example 3 was finish time was 25 days. Okay. So like this is the original solution for example 3 is, we start with time 0 and go and duration was 25 days, 25 days. So there is a critical path A, B, F, I, L, and project finish. Okay. So this was our critical path, and these are total float are shown here. For the critical path, all total float are 0. And but for C is 1, for D is 3 days, for I is 1 day, for G is 3 days, 11 minus 8 is 3 days, for J is 5 days, 20 minus 15, 5 days, for H is 15 minus 12 is 3 days, similarly for K is 3 days. Okay. So this is like is given the total example number 3. Now we are going to apply on this example that finish date is 28. So instead of starting with the finish date is a backward pass. So finish date is 28. So here we will put a 28 instead of 5, and then we come back with 28. Okay. So see how the diagram look like. Now when we put this here. In the previous slide here was 25. Now we put 28. So this 28 will come here minus 3, 25. This 28 will come here minus 2, 26. So we come until in the beginning. So see a backward pass. So we got a total float for A is plus 3. So what happened because before schedule was 25 days. Now the finish date is 28. So it means that when you put that, so critical path will disappear. So all critical path like activity A, there is 3 days float. B, there is 3 days float. F, there is 3 days float. And similarly, I, there is a 3 days float. So L, there is a 3 days float. So you would increase the duration from 25 to 28. So 3 days. So it means on the critical path, every activity is showing total float is 3 days more. Okay. So instead of 0, it's showing 3 days. Okay. So this is like, it's how because imposed finish date is greater than what we have calculated before. Okay. So now imposed finish date is greater than. So it means we can finish our project on day 25, but the contract requires give us time 28 days. Okay. So it means we are better off in this case. So let's practice the other way. Second example is that now put imposed finish date is 22. Okay, it is less than 25. So less than the project equation, what we have normally calculated before. So we go back with 22. 22 comes here, minus 3 is 19. 22 comes here, minus 2 is 20. Similarly, we do all with all those activities. So now you can see that because it's the calculated date was 25 and your imposed finish date is 22. So it's 3 days lesser. So now you can see all the critical activities, there is a total float of -3 for B, -3 for F, and -3 for I, and -3 for L. So what it indicates that our schedule is already 25 days, and owner is asking for to finish the project in 22 days. Okay, so it means either we should crash the schedule. Okay, so reduce this critical path is there is a negative float. Negative float showing that we will finish the project late 3 days. Okay, we'll finish the project late 3 days. So either we should get time extension if owner can give, or we should crash the schedule. Okay, so this is like imposed finish date is less than the calculated date. So in that case, we will get the negative float. Okay? So this is not a good situation that our calculated schedule we plan to finish on 25 days, but owner's contract time is just 22 days. Okay? So with this, now we got the idea about what is meant by negative float. So negative float is a situation that occurs when performing an activity even on its early dates fail to meet the project's imposed finish date or other constraints. So now you see that if we go back in the previous what they have, like here early start was 0, but our early start, early finish, late start, late finish. So late start is -3. So here is our early start is 5 and late start is 2. 2 days, day number 2. So similarly for is for F is early start is 11 and early start, early finish is 15. So late start is 8. Late start is 8, but early start is 11. So see, it's late start should be higher, you know. So this is what they are talking here. That negative float is a situation that occurs when performing an activity even at its early start that fails to meet the project imposed finish date or constraints. Okay, negative float means your schedule is already behind. Negative float appears in a schedule when the early dates of an activity are later than the late dates. So when the early start date of an activity are late, okay, later than even the late start date of those activities. Okay. So negative float, as the name implies, is an undesirable thing to occur, and it indicates a delay in the project. Negative float means that we are going to the project delay, or we have to face liquidated damages. You know, in that case, or we should crash the project. Okay. So negative float can develop in one of the two cases before construction start. Okay, before construction start. So then, if before construction start there is a negative float, it means to handle negative float, the contractor need to compress the schedule, or the owner has to allow a longer time frame, or owner should give the time extension. Okay, if you have to follow your schedule, or you need to compress your schedule. So during construction, what happened? Contractor need to prepare a recovery schedule or face the possibility of liquid damages during construction. So contractor, they need to prepare the recovery schedule, so they may enhance labor force or equipment to finish the project on time, or they have to pay the liquid damages. Okay. Or there is a sometime, you know, owner, they ask for constructive acceleration. This is very tricky, you know, constructive acceleration. So we will explain. A constructive acceleration claim is when the contractor incurs added cost to complete the contract on time, when it should be given extension of time based on excusable delays. So it means there is no fault of the contractor. Delay not caused by the contractor. Excusable delays are those that the delays are not caused by the contractor. So it means owner is at fault. Owner is at fault. So there is no fault from the contractor side. Maybe there is a delay in the drawings or whatever. So the owner is responsible for the delay. But in that case, even sometimes owner they press to the force to the contractor. So it is the acceleration of the work following failure by the employer to recognize that the contractor has imposed employer's delay for which the contractor is entitled to an extension of time. So a contractor is entitled to an extension of time, but owner is not ready to give the extension of time, and which failure required the contractor to accelerate its progress in order to complete the work by the contract completion date. So sometimes, the owners are also, they have a restriction, like there is an Olympic game, there is an Asian game, there is something. So stadiums, all those venues must be completed before the event. So owner cannot increase the date. So by that, they are asking for a constructive acceleration, acceleration of the project. So they don't want to give any time extension, and they are asking the contractor to speed up the project, they complete the project on time or face liquidated damages. Constructive acceleration occurs in the absence of an owner's directed acceleration. Directed acceleration means owner order that you can speed up the project. So if owner asks this thing, then it means for bringing speeding up, like bringing more labor force or more equipment. So contractor can ask for additional cost. Whereas the owner has this is what we call the directed acceleration. But in case of constructive acceleration, where the owner has refused a valid request for time extension. The classic case is when a request for a time extension for excusable delay is denied and the contract provides liquidated damages for late completion. So in that case, the owner is not ready to give you time extension, but they are asking to complete the project on time or face the liquidated damages. This is I try to explain constructive acceleration. Now, working with calendars, each activity has to be assigned a calendar. Okay. So certain crews may follow different calendars. Okay, it's possible that, for example, the entire project team may work for 5 days per week, except one crew that works 6 days or 7 days a week. Okay, so we can assign separate calendar to one crew. The same crew may work 5 days a week at normal time, then switch to 6 or 7 days per week. Okay, so we can adjust, if some crew they want to work for 6 days or 7 days. So we just let the project wherever is sometimes this practical situation, we ask that, okay, only this team will work over the weekend, So then we can assign these for those crews who will be working over the weekend. Again, calendar computer scheduling program can handle this issue. The user has to be careful in the implementation of this. Like there is a global calendar, there is a default, and there is other local calendars also. So you need to do is recurring regular holidays. So you need to recognize what are the national holidays. What if a holiday happen over the weekend? So we need to check if the government will give a compulsory leave. So or the labor force will work, on that day. So we have to adjust the schedule accordingly. Work hours per day, how much work hours per day? Like 8 hours per day usually, it's okay. So what is the resource calendar? So we can assign, for different resources, different calendars, okay. Scheduling is in other countries follow local holidays, okay. So whenever you are working in other countries, so follow the local calendar, like local public holidays, local national holidays, whatever, Then non-work days, schedulers must take in account non-work days. Okay, this includes like when we set the calendar, so schedule non-work days such as what are the holidays, okay, what are the shutdowns. So we can put. So when we go to the Brahmavira, we can see that like we can mark this like in Saudi Arabia is. We have Friday's holiday or Saturday's holidays. We can say that Friday and Saturday is non-working day. Okay, and we can assign that holidays for the Yom al-Watani, or we can assign the holidays for Eid al-Fitr, Eid al-Azha, or in USA, so they assign the holidays for Christmas or whatever, their national holidays. Unscheduled non-work days, such as if there is a rainy day where there is severe weather, so there will not be work on site, or there is a snowfall, something, so we have to put that in the schedule. Other unforeseen interruptions, if an unforeseen interruption comes, so incorporate those with your schedule. Okay. So guys, with this, we have finished this, chapter number 4, part 2. Part 2, we have taken more time, but it was necessary to explain some things. Otherwise, I need to skip all the diagrams, with the forward pass, backward pass, and total float and free float. So we learned all these things, how to, work with the constraints or with the lag, how we can draw the diagram with when lag is given, or what are the impact of imposed finish date, or what is mean by negative float. Okay. So what is mean by management float or time contingency, and we also then learn about constructive acceleration and different crews following different calendars, or we have to follow the calendar with the local holidays, local schedule, so working with calendars, we need to get familiar, so to work with the calendars also. With this, gentlemen, we have finished this chapter 4, and thank you very much for your attention. So inshallah, next time we will discuss the next chapter, chapter number 5. Okay. So just say, كفارة مجلس سبحانك اللهم وبحمدك أشهد أن لا إله إلا أنت نستغفرك ونتوب إليك. Thank you very much for your kind attention. Inshallah, we will discuss next chapter next time. Assalamu alaikum wa rahmatullahi wa barakatuh.